Well, students, welcome to the last confidence interval video. This is going to be confidence intervals for population proportions. What I'm going to do is talk to you a little bit about before and after what we've done up to now. So before, what we've done essentially in sections 6.1 and 6.2 is we have used the sample mean and the sample standard deviation to help estimate. We've used them as point estimates of the population mean standard deviation. And then we've used the sample size and the confidence level to basically find a critical value and a margin of error. And then from that margin of error, we will add and subtract it to the sample mean, and that will give us a confidence interval. The data that this is about is always quantitative data because it's a sample mean, and means always can only be found with quantitative data. So what does that take us to? In section 6.3, the now, we're going to use the population proportion of a sample. So again, this is a sample population proportion, and we're going to use that to approximate, it's a sample proportion we're going to use to approximate the population proportion. It turns out the standard deviation of the sample, which can also be written as S, the symbol typically used is still sigma, and we use that to approximate the population standard deviation. We're going to have a sample size, we're going to have a confidence level, and what we're going to do is we're going to find critical values, and then this is the new formula for margin of error, which is a critical value times the square root of this whole fraction, which is p hat q hat over n. And now if you remember, we talked about p and q way back in chapter 4 before Christmas break. And P and Q are actually come from the number of successes out of a total. So P hat is actually equal to X out of N, where X is the number of successes. And then Q hat is always 1 minus P hat. And that'll give us the sample proportions. And now, this is always for qualitative data. Why is it qualitative data? Well, because we're saying what percent of people have brown eyes, or what percent of people get their homework done on time. And so that becomes our probability of success, or our proportion of success. And that's how we do the problems. So what we're going to do is we're going to do an example of how you make a confidence interval. And you'll see it's just like what we've done before. So here's a typical problem. Of 848 students surveyed, 144 plan to join a volunteer group in the future. Find a 99% confidence interval for the proportion of volunteer planners. Now, how are we going to do this? Well, the first thing we want to do is we want to line out what data that we have. So number one, we know X is 144. We know N is the whole sample size, which is 848. We know the confidence level is 99%. And from this information, we can find everything we need to find. First thing we'd like to find is we'd like to find the sample proportion P hat. And that's pretty simple to do. That's just X over the sample size, which is equal to 144 divided by 848, which is equal to 0.1698. From this, we can find Q hat, which is equal to 1 minus 0.1698, which is equal to 0.8302. And that's the Q hat that we'll need later in the problem. So now we have everything that we need. From the at this point, we need to find the critical Z and the margin of error. So the critical z, as we've always done before, we're using a z interval instead of a t now. So this 0.99, that means the area in the tails, each tail is 0.005. And so what we did before is we would do an inverse z, or inverse normal, with 0.005. Since standard normal, we'd use 0, 1. And when we do that, we would get that was equal to plus or minus 2.58 standard deviations above or below the mean. Now, once we have that, then we can move forward to working on the margin of error. So what's the margin of error going to be? Well, since this is a proportion, 148 out of 848, a population proportion, the margin of error is going to be the critical value times the square root of p hat q hat divided by n. So in our case, it's 2.58 plus or minus times the square root 0.1698 times 0.8302, maybe I'll do this in parentheses, divided by 848. And so once we do that, then our margin of error is equal to, I'll figure it out for you, 2.58 times second square root 0.1698 times 0.8302 divided by 848, and when I do that I get 0.0333, and therefore I can find the confidence interval. I take the sample proportion 0.1698 and I subtract 0.0333, and I take the sample proportion 0.1698 and I add 0.0333, and so therefore my confidence interval is going to be first 0.1365, and the second one is going to be 0.2031. Now, since these confidence intervals are always qualitative and they're always a proportion, what that means is that each one of these confidence intervals is really a percentage of the total. So if you'll remember, we had students who were going to, what percentage of students were going to volunteer after they went to school? Well, in this case, the confidence interval would be 13.65% of students to 20.31% of students. Okay? And all confidence intervals for proportions are always in a percentage like this. So you want to keep that in mind as you make the confidence intervals. Notice how I kept everything in decimals until I figured it out, and then I changed it to a percent. So therefore, we can say this, that since this was a 99% interval, we can say we are 99% confident that the interval from 13.65% to 20.31% of the student population contains the true proportion of students who wish to join a volunteer group. Okay? Now notice how that refers back to the original problem. Let's go back and look. The original problem was, of 848 students surveyed, 144 plan to join a volunteer group in the future. So they want us to find a confidence interval. So now by conclusion, we are 99% confident that the interval from 13.65% to 20.31% of the student population contains the true proportion of students who wish to join a volunteer group. Okay? Now notice how we're confident that the interval represents or contains the true proportion of those who wish to be in a volunteer group. So it refers back to the original problem. This is what I want you to do on every part of this assignment. Now, as always, there is a calculator statement, and that calculator statement is under Stat, then Test, and in this case it's number 5. It's called the one proportion z-test, and that's because we have one proportion. So the one proportion z-test, if I press that, what's it ask me for? Well, first it asks me, pardon me, I said that wrong. It's the one proportion z interval, and the one proportion z interval is letter A, not number 5, it's letter A. So pardon me, one proportion z interval, so make sure you get that correct, one proportion z interval, because we're doing z intervals. And if I press that, then what's it ask me for? It asks me for x, which was 144. It'll ask me for the sample size, which was 848. And it'll ask me for the confidence level, which in our case was 0.99. At that point, it'll just ask me to paste or calculate, and when I do that, it gives me the one proportion z interval. And the interval I get is, except for a small decimal point, I got 0.1366 and 0.2030, is very close to what I got from before. So you can see that technology saves a lot of time, so I would encourage you to use that as much as you can in class tomorrow. Okay, so now we've solved the technology issue, so there's one more thing that we need to take care of. And that one more thing is that the textbook asks you for is to find a sample size that'll give you a certain margin of error. And so what do we do for the sample size? We use a formula. We take the margin of error formula, which I have written right here. We take that and we solve for n, and when we solve for n, we get n equals p hat q hat times the critical value over the margin of error squared. And this is going to be the same kind of problems we've done before. I'm looking at problem 22 or 21. It says you're a travel agent, you wish to estimate with 95% confidence the proportion of vacationers who plan to travel outside the United States in the next 12 months. Your estimate must be accurate within 3%. All right? And so find the minimum sample size needed. All right. And so then based on that, and they actually give a P hat, Q hat of 26%, said they plan to travel outside the U.S. So what would P hat be? Be 0.26. What would Q hat be? 0.74. The critical value of Z for 95% is 1.96. You'd square that, and the margin of error, they told us, was 3%. So you just have to multiply those things out and get the sample size. So it's not too hard. What if they don't give you an estimate for P hat? Well, if they don't give you an estimate for P hat, then what you always use is 50%, because in that case you would assume that things are equal. And that's all I have for you in this video. It's about 15 minutes. You should be ready to do all 30 problems tomorrow, 2 through 30. Okay, thanks.